Hey, I want to make a video on component replication in Unreal. So here we have some tests and we have these boxes. This box will spawn a component on the server and this box will remove the component on the server. And to start up the discussion, we'll try and spawn a static mesh that spawns a tree onto the actor. So here's the tree and this one has a different tree. If I play, we can see that by default, if we try and spawn a component, the client never sees it. The server attempted to spawn it here, and the server will remove it here, but we never actually see it on the client. However, if the component is set to replicate, we can have the server spawn the component, and the server remove the component, and that's all happening server-side. So the server is adding and removing, and that's replicating down to the client. We'll dive more into the code a bit later after some tests, but you can see here that we are newing up a new static mesh component. And if we have a bool set to replicate, we will set that component to replicated. We'll set the static mesh data, attach it to the root component, set its relative location, set a scale, and register the component. And so this is all happening on the server due to a has authority check. And we're using a spawner to spawn it onto a target actor. And so the only difference between those two spawners is one of them had this bool checked that made the component replicate. And components are just like actors in terms of what they can do with replication. We'll get more into that, but basically this static mesh that we set is going to set a mesh internally here. And that static mesh is replicated using an onRep. And so components aren't magic. You still need to do your typical replicated variables and whatnot. And so if we take a deeper look at the tests we have here, there are three types of actors that we're going to add a component to. There is a replicated actor that is dormant awake. I have this represented as red because this is like the most expensive in terms of network performance. This is constantly checking for replication and whatnot. Then we have a replicated actor, which has a dormancy dormant all. So this goes dormant or like asleep. And it's a little bit better in terms of network performance. So I made it blue, not red, because we are dormant. So we're not always replicating. We're only replicating when we flush dormancy or change the dormancy behavior. You can see my video on Dormancy for that. And then lastly, we have a actor that is just not replicated at all. And this one is the best for replication performance because there just is no replication. So it's green. And just so you can see that, this is the green actor. The replicates is false. The dormant one, you can see it replicates, but it is dormant all. The red one, you can see that it is replicates, and you don't see a dormancy here because it is default dormancy, which is awake for this actor. So dormancy is awake. And so for the awake dormancy replicated actor, things work very smoothly. It just is constantly popping in and out based off of when we spawn it. And that's just how you would expect it to work. Things get a little more complex when we enter the dormancy scenario. So we have this actor that is dormant. I try and spawn it. We see that the server did attempt to spawn the static mesh, but we never see it on the client. And I go over here, and we see that the server did attempt to remove it, but we never saw it on the client, so we never saw it get removed. So if you're in the scenario of having dormant actors and you need to add components to them, you need to do a little bit more setup. And so if we look at the spawner, I have some settings here that is spawn dormancy setting and despawn dormancy setting. And right now we're doing nothing. But I can flush dormancy, I can awake it briefly, or I can do both. And spoiler alert, all you really need to do is flush. So I'll set both of these to flush, and I'll try that. So there we have our dormant actor, and if I try spawning the component now, we see that it was able to spawn the static mesh. And if I remove the component, it's gone. So all it really took was a dormancy flush, and I'll get into the code for that in a moment. There is some other caveats. We can do that flush before we create it, or we can do it after we create it. So before it, we leave this checked. After, we uncheck it. This doesn't really have an effect on whether or not the component shows up. However, the dormancy flush for destroying does. Note, the documentation says that you should always flush before changing replicated state. So while it sometimes works flushing after, you should flush before you change any sort of replicated state. And that ensures that your replicated state will come down correctly and nothing will be lost. You can see my video on Dormancy for more information. So tweak dormancy before destroy means we're going to flush it before destroy when this is checked. If I uncheck it, then we're going to flush it after the destroy, because the checked is before. So if I test that real quick, you can see that we spawned it. But if I go and remove it, because we flushed after, so because we flushed after, this being false, it wasn't able to detect it at the appropriate time, and so the client kind of got stuck with the component. So the client didn't receive that message before basically the actor went dormant. So if we check that, so do it before we destroy, so we're effectively flushing before we destroy, while it still has the component, and then we destroy the component, it's able to detect it. And so it's a slight caveat you should be aware of. As for creating, it doesn't matter, before, after the actor component's already there. Again, note, if we were doing this proper, we would be flushing before we change any replicated state. So I'll uncheck that, and we can see that it has no effect on the dormant actor and actor spawning. It's really the destroy. You want to make sure with destroy that it is flushing or making it awake before we destroy the component. Okay, so I'll set these back to default. So now this is no longer going to work unless we start flushing. If I look at the code, just so you can see that briefly before we do a deep dive, we have this spawn component. And then if we have tweak dormancy after create for spawn component, then it's going to update the dormancy for the event. And this is going to handle either flushing it or changing it to awake or doing both. Or if we have that bool set, and if we go back to spawn component, so if it's not after create, then we're doing it before. If it's after create, then down here after we create the components, then it tweaks the dormancy. Again, we should be flushing before we change the replicated state. And the same thing for despawn, the bool's a little bit flipped so that we program for the happy path first. And the despawn, it says tweak dormancy before destroy, which is the good situation. So we update the dormancy, it's the same function. It either flushes or makes it awake for a time, or does both. If that bool is false, then we destroy the components first, and then we change the dormancy. And so that's all the code is for that. Now, if we look at the third scenario, where we have a not replicated actor, I'd be curious to hear what your expectation for this scenario is. We have a not replicated actor, but we have a replicated component. So is the fact that the component is replicated, is that enough to make it arrive on the client? Or is the not replicated actor somehow going to block this? Think about what you would guess there, and I'm going to test it now. And so you can see it didn't actually spawn the replicated component to the actor. We saw that there was a print string on the server that it tried to, or it did spawn it on the server. And if we go over here, you can see it removes it on the server. But because the target actor itself is not replicated, it doesn't really matter that the component is replicated. We're not able to send the component down to the client. Now we have a slightly different situation. Here, the actors are hand placed on the level. There's instances hand placed on the level. But what about dynamic actor spawning? So here, it spawns an actor, and then shortly later, it spawns a static mesh component on it. So there's a slight delay there. And then we're able to remove it. The actor stays in place just because of the way I've set up the test. But this was a replicated actor, and its dormancy was awake. So it's the most expensive situation. Now, this is going to test the same situation over here, where we have a dormant actor spawned, and then we try and spawn a component on it. However, there's going to be no flushing, so it's not going to work. We spawn the actor, we attempt to spawn the component, but the component never came down because we never flushed it. And then we can remove it, and we were none the wiser on the client. Now, if I change this one to also flush, and it's going to flush after we create. Again, note, if we were doing this proper, we would be flushing before we change any replicated state. And flush before we destroy. We can see that this should start working. So spawn the actor, and bam, there's the component. And then if we remove the component, it removed, it was able to flush and detect that a change happened. So the last situation is spawning a not replicated actor and then spawning a component on it. And in this situation, since the actor is not replicated, we never even see it on the client. So one, we never have the actor, and two, we don't get a component because we didn't have the actor in the first place, and the actor wasn't replicated. So there's a lot going against this scenario. But hopefully those scenarios make sense. And that's all well and great, spawning a static mesh, but more likely you're going to want to create your own components for composition that have your own logic and whatnot. And so these tests actually test a plain old actor component. And so at the end, we'll look a little bit deeper at the code here. So here we have a actor component, my replicated actor component, and it is inheriting from just actor component. So there's no spatial aspect to this. It's just more like a data component or a logic component. It's not a scene component, so it won't be added to the scene tree. And in its constructor, I'm setting it to replicate it by default. This is how to do that for components. It's slightly different looking than actors, which allows you to just set the bool to true. Anyways, so we'll dive into the code a bit deeper later. What's important is that we have a replicated variable. So we have an int counter, and it has an onRep function, and the onRep has a previous value. So we can see a delta, and when we increment this, you can see my videos on replicated properties for more information, but effectively we have a heartbeat that's incrementing this counter. And we also have a RPC. So this is a net multicast and it is reliable for demonstration purposes. We provide a value to that RPC, and that RPC sends it down from the server to the client because it's a net multicast. It also executes on the server. And we do some printing when this happens, and we also do some printing in this onRep when that happens. And what this component does is it has a loop time, and it's accumulating time into these two variables, and when enough time accumulates, it increments this, or it calls the RPC. And so let's test and see what that looks like. Again, the first test is on this replicated actor that has the dormancy awake. And since there's no spatial component to this actor component, you should just rely on the print strings at the top left. So you can see we spawned it here. We see that the server spawned it, and we got a print message that the server was trying to spawn it, and then we got it on the client. So now we know that it's on the client now. And then the red is from the onRep. So we see the onRep happened from the heartbeat. And the purple and pinkish colors are from the RPCs. We see that the server is calling the RPC and the clients are getting the RPC. So we know the component is on the client because we saw the begin play, and we're seeing the onReps get called, and we're seeing the RPCs get called. So that logic component made it to the client. And like in the static mesh case, we can remove it, and we see that the server called its in-play, and we saw the server print that it was destroying the component, and we also see the in-play on the client. Now we'll run into the same situation with the dormant actor scenario. So if I try to spawn it and the actor is dormant, we saw that it basically only had the begin play called for the server initially, but there was a slight caveat in that when the RPC was called, we suddenly got the component spawned on the client. And so you can see my dormancy video for more information on that, but effectively it calls the flush when that RPC was called, or so it seems. So we can remove it, and you see that we only had the in-play on the server. And so the client is still potentially having the component here. The heartbeat happened on the server, so we're not seeing any RPCs or replicated variables. But if we try and spawn the component here, and we get the RPC, we did get an RPC on the client. And so we are having a sort of scenario. Finally got the begin play. It's late, and so what we can do is change the dormancy here to flush, just like we did for the static mesh. And so when we create the component, we get a flush, and now we see the correct scenario, or the more ideal scenario, where we get a begin play for both the client and for the server, that in green. And we've got our RPCs and rep variables happening. And then if I remove the component, you can see we got the in play for both the client and the server, as we were expecting. And so you still need to take care with dormancy, even for logic components. The logic component's a little more forgiving, since when we call that RPC, it causes a flush for us, it seems. But nevertheless, you should be aware of dormancy when setting up something like that. So with the defaults without flushing, you'll notice that the client doesn't get its begin play until the RPC gets called. So in green, we got the server begin play, but we have to wait. We just got our green client begin play, and that was because the RPC was called. There is another important thing to note with dormancy and flushing. So keep track of how many begin plays you see called for the component. They're going to be printed in green, and we're not going to get the begin play until we get the first RPC call, right? But then I'm going to destroy it, and then I'm going to spawn it again. Now I'm spawning it under the same name in code. So by that, I mean in this new object, I'm giving it the same spawned test component name. So I'm going to spawn it again and watch for that begin play. So first, we're going to spawn it. We only got one green server begin play. The RPC will kick off the client begin play. There it is. And I'm going to remove it. And we got the server in play, but we did not get the client in play. Now, if I go to spawn another component, we got the server begin play, and we should get an RPC, and we just got an RPC. I did not see another client begin play, And so what I believe is happening in this scenario is we still have that actor component present on the client. And since we never flushed when it was destroyed, because we never have an RPC to call the flush, the client kept the component around. And when the server spawned another component, it did so with the same name. And then when that one called into RPC, it flushed, and the client still thought it had the component. So it just intercepted that RPC. And so you can end up in a scenario where you wanted your component to be destroyed on the client, but since you never flushed the dormancy, it never was. And then a new component was created, and now it's receiving RPCs for that other component, and there's sort of a desync potentially happening there. So just be aware of that when setting up a dormant actor. You need to basically ensure that you're communicating with your clients. At least that's how I believe this is working. This is a pretty niche scenario, but could happen under some gameplay systems. And again, you can go back to earlier in the video and see, but really all you have to do is flush at the right time. And this is only present for the scenario of having dormant actors that are sometimes dormant and not. And so lastly, we have the not replicated actor. And just like the static mesh component version of replicating a component, we spawn it on the server. But because the actor is not replicated, it never makes it to the client. And all we really see is the RPC being called on the server only. We're not getting any replicated variable or anything like that. See my video on replicated variables to see the distinction between code and blueprint. Because it's a code replicated variable, we're not having it called even when the server sets it. But on blueprint, we would see the server having an onRep or a rep notify being called. So we delete the component, and we got the in play on the server. The client was never aware of the component. And sometimes this is a feature you might want. So just be aware of it. And then we can dynamically spawn those actors and get the similar behavior. So we spawned an actor that is awake, and we saw the begin plays for the components. And then we can remove it, and the component got removed. And we run into the same dormancy scenario. So we spawned an actor that went dormant, and then we didn't get the component until the RPC. And remove it. And what we want is to add some flushes there to shore that up. And lastly, if we try and spawn a not replicated actor and then spawn a component on that, we're just not going to see that on the client. So we saw the server actor begin play. We see the server trying to spawn the component. And now we see the RPC only on the server side. We never see the RPC to the client because we don't have the actor, and two, we don't have a component. And so that's a lot of different scenarios to consider, but I hope that made sense. Let's just take a quick look at the code. I'm going to navigate down this code. You can pause at any point. I'll talk to a little bit of it, I suppose. That was the header, and here's the CPP. Okay, just to talk through it at a high level, we have that replicated component, which is a logic actor component, and it has to get lifetime replicated properties, just like regular actor replicated properties. And you can do pushed or legacy replication. That looks like this over here. We have a property, has its onRep, and when we modify it, we have to mark it dirty. So if I search for that, you can see in the push replication, we had to mark it dirty. It also supports RPCs, just like regular actor RPCs. See my video on that, but you have to do the underscore implementation. You can send a value, and we print the value. We had a heartbeat, so in begin play, we did some printing of the current state so you could see it, and the roll. And then we set a heartbeat timer, and we accumulate some time to know when to send the RPC versus the replicated variable. And in that heartbeat, we update the times. Oh, and on in-play, we just print to the screen in-play so we can see when that actually happens on the server versus the client. Anyways, in the heartbeat, we update some times on the server. So we just basically accumulate time into these variables, and then after it passes the loop time, we loop around the time back to 0 with a remainder, increment our counter, mark it dirty so it gets replicated to the client. Or if in the case of the RPC, we have a separate variable accumulating time, loop it around, keep the remainder, call the multicast RPC only when we're beyond the time. We have our onRep, which just prints out the old value versus the new value. We have our multicast RPC, which effectively does a similar thing. It prints out the RPC parameter, and it prints out the counter's current value. We have this component attacher actor, which is just an actor. It is not replicated, doesn't tick, and in begin play, it doesn't really do anything. But what it does do is in Blueprint, there is that overlap. So if I open up this actor, you can see on component overlapped, the add box which is an add box here, and component overlap on the remove box, which here's the add box and here's the remove box. All it does is either start the spawn sequence or just spawns the component directly if we already have the target actor. Or on remove, it just despawns the component. So if we look at what that looks like in the code, we have the start spawn sequence, which just does basically a delayed actor spawn if there is a delay. And then it does a delayed component spawn if there is a component. The spawn actor just spawns an actor if we don't have a target, and we have a class to spawn, and we're the authority, so the server uses the world, spawns an actor. Spawn component does a similar thing. Do we have a target actor to put the component on, and are we on the authority, so are we the server? It does some dormancy flushes potentially. This is just a function that will flush the dormancy if that setting is on flush that I made. It's just an enum that I've made here. It's not anything special. It's an enum, so do nothing, flush, awake the dormancy briefly, or flush and awake. And really the trick was flushing. It's just flushing at the right time. And so update dormancy for event, flush, or awake, or do both. And so if we go back to the spawn component will potentially flush if we have the setting to do it before the create, or it'll flush after if we have the setting to do it after. Again, note, if we were doing this proper, we would be flushing before we change any replicated state. And then if we have a component to spawn, so it's like the logical component, first we attempt to find it so we don't spawn it twice. If we don't find it, then we new up the object, so create a new component, and then we set the attachment if it's a scene component only. So it doesn't have to necessarily only be logic, it can be in the scene tree. So cast it to a scene component, if it's a scene component, set up the attachment, then we register the component. Else, if we have a static mesh to spawn, so if we didn't have a logic one, we'll see if we can find the static mesh, which just does some checking. It loops over all static meshes and see if it has a mesh with the same static mesh. If so, then we consider that the one we spawned. So if it doesn't already have the static mesh, then it spawns it. And if we have it set to replicate, then we'll set it to replicate. We configure it in either case of relative to the root in a certain scale, and then we print that we tried to spawn it. And then at the end, if the setting is to tweak the dormancy after we create, then we do our flushing if we need to do any flushing. The despawn component is similar. If we have a target actor and authority, then what we're going to do is try and flush if we have the setting enabled. Again, we should be flushing before we change the replicated state. If we have the setting to try our dormancy tweaks before we destroy, which is the correct case, so we will spawn the logical component. First, we try to destroy the component by finding component by class. So if we have that logical component, destroy it. Then we try and find the static mesh component. And if we find it, destroy the static mesh component. And then conditionally, based on the current settings, we flush at the end. So this is what you want to avoid. You want to make sure you flush before the component gets destroyed. And then lastly, we have that update dormancy for event. And so I already covered that update dormancy for event. This just either flushes or makes it go awake. And here's our function to find the static mesh. And that's the code changes. I hope that makes sense. Hope that helps introduce you to component replication. Maybe there's some cases I missed here. Let me know in the comments if that's the case. And let me know if you have any comments, concerns, or even corrections. And until next time.